You are here.
Okay.
Thank you. Thank you for accepting our request. We
Yeah,
are
no,
very
no. Of,
happy.
of of course, no. I am happy to be here. So thank thank you very much for having me. I believe you guys should be able to see my screen, so I'm gonna assume you guys can, and I will continue until someone tells me otherwise.
Yes, we can.
Awesome. So yeah, today's talk is going to be about building progressive web apps. As kind of mentioned earlier, my name is Michael Salati. I am primarily a web developer. Like that's been my background. I've been coding on the web since like 2015, I think. And I happen to be a developer program engineer at Google. It's not that exciting. I mean, working at Google has been an exciting experience, but I specifically work on a platform called web.dev. If you've seen it, awesome, you know what it is. If you haven't seen it, I definitely recommend you guys taking a look at it later on today. It is a kind of one-stop shop for resources, learning tools about technologies for the web and how you could, and providing guides and like information on being a better web developer. So definitely recommend checking that out. But I mentioned before, I love the web. I've been on the web forever. I grew up on the web, and I remember how things were like in the I remember how things were like in the 90s, the 2000s, and now in our modern web environment. And I love it. It's compelling, it's exciting, and we have these incredible tools to make amazing and compelling experiences for others. My experience with the web started with a framework technology called Meteor and Blaze. Then I dove into Angular, and now I'm much more well-rounded. So like, I will show some Angular code, but I'll also cover like different frameworks and framework agnostic solutions because I think that's really important for a wider breadth of developers who would be interested in this. This is a throwaway joke. The mass product is memes as a service, so it's a side business I run for delivering memes as a postcard. But I guess the most important thing I want to say here is I have made a lot of mistakes, and I mean a lot. So I'm hoping that maybe I can share some of the things I had to learn painfully when it came to developing PWAs. That way you don't have to make those same mistakes or have those same pain points that I've had. So what exactly is a PWA? And the answer, I would say, it's pretty simple. It's not this. A PWA is not this. No. PWAs shouldn't be like that. PWAs are just web applications that provide amazing experiences because they're fast. They respond quickly, whether that's loading or responding to user interactions. They're integrated. They show up on the home screen and have access to things like sensors and can handle push notifications. They are reliable. They'll load instantly, and they'll never show that dinosaur, no matter how much fun of a game it can be when you're offline. And lastly, they are engaging. They feel like a natural app on a user's device with an immersive user experience. Now, I used to make a joke because, you know, fast, integrated, reliable, engaging, it's fire. And I really like Chappelle's Show. I wanted to find a joke that would work for this. I never got there, so I'm just going to leave this here, and just have you guys come up with a joke that's funny for yourselves, and hopefully just enjoy this. So why PWAs? Users spend most of their time in native apps rather than websites, and that's because native apps end up feeling more reliable to users. They're available on a user's home screen. They typically have some offline experience or a completely offline experience. And they do things that websites don't really do that often that make them feel more like, just feel better, like push notifications and stuff like that. So, and another thing is that space on a home screen is highly valuable. 78% of the time that users spend on their phones are in their 3 favorite apps. And so what you're really asking for when you're making an application that you want users to install onto their devices is it's a commitment for time and space on their home screen. And it's hard to make that commitment because on average, people don't really install apps from the Play Store or the App Store, whereas they're more likely to visit a website for like these short bursts or short engagements at a time. Building a high-quality PWA can end up having incredible benefits for you. PWAs are essentially web applications that provide these near-native experiences on mobile devices. When the criteria for a PWA are met, Chrome will actually prompt a user to install a PWA onto their home screen. And once on their home screen, they work more like a native application because they'll have technologies like a service worker, which will allow you to cache assets and load things offline. It'll allow you to handle push notifications, meaning your users can get updates and be re-engaged into your web application. And when users are typically averse to installing applications from the Play Store or the App Store and would rather visit a website, a lower barrier to entry like a website might be all you need to be a citizen of their home screen. Now, native apps start quickly, they work in the background, offline, and they have access to all different types of sensors. But the problem with that is when developing a native application, you typically need to have different versions of the application for different platforms. Versus web applications, they end up having a greater reach than native applications because you can invest your time and effort developing only one application that will run on virtually any and every platform. And they can end up being safer than native applications in some cases. But we as web developers need to be better about introducing features that native applications seem to have into our web applications. Now, a great example of how this works and how this could look, I think, is the Twitter PWA. I'm just going to run this video. I ended up installing the Twitter PWA on my device. I started using it maybe like a year or two ago. And right from this get-go here, you can see as I'm scrolling, things are loading in smoothly and quickly. I can create a new Twitter post as expected. And if I wanted to attach an image, I could pop open my camera, take a picture right away, and just it shows up as part of my post, just how I would expect my native application to be. And this experience ended up being really, really compelling for me because it provided, like, I didn't really notice that big of a difference or any difference really between the web application and the native application. But the big difference came one day when I was looking at the apps I had installed on my phone. So I'm in my phone settings. I'm looking at the apps. I get to Twitter. I see the PWA and the native application, and both of them say that they're taking about 250. The storage amount was like 250. And I didn't really pay that much attention to it until I took just a little bit more of a look where I realized that, yes, it was 250 versus 250, but the native application was taking 250 megabytes on my device versus the web application was taking 250 kilobytes on my device. And once I saw the disparity, which is close to 1,000% difference in size, I just stuck with the web application because I had virtually the same experience for a fraction of the cost. And in this case, cost being just storage. Anyway, let's talk about our PWA that I threw together for this application. And here it is. It's pretty simple. It's an application designed to showcase popular movies, and you can click into a movie to view more details. It kind of looks like a Android application, or at least an Android tablet application, just because it ends up following these material design guidelines, as well as doing a few performance bits under the hood just to make it feel fast and smooth. All important things to kind of give that native application feel. But does this application really fit as a PWA? It's definitely a web application, but the best way we can test if it's a PWA is to run it through a suite of tools called Lighthouse. So I'm just going to run these Lighthouse tests on the application here, and as it goes, it'll end up generating a score. And the rating's not good. You can see definitely a few different red squares, red triangles, and not that much green. So Lighthouse is testing for 13 different things, and of those 13 things, I am only meeting 5 of them. So this application, as it stands right now, is definitely not a progressive web application. It's just a website or a web app. So where are we falling short? The first thing is that this website does not load when a user is offline. If we're building a PWA, it needs to work offline. And the best way for it to work is to implement a service worker. As it stands, the app doesn't use a service worker. The service worker is going to be the thing that lets us use things like offline. It's one of the features one of the things that's required to be able to add a PWA to a user's home screen, and it supports push notifications as well. The other thing that's required for being installed into a user's home screen is the web app manifest file. And it kind of sets the definition of how the web application is going to behave when it's installed onto a device like a native app. So it defines things like the app name, theme colors, and stuff like that, and icons for the app. But it also is used to set the splash screens. So when you open a native application on your device, you might see the solid colored background for a quick second and the logo until the information of the application loads in. So the web app manifest sets this, and as it stands right now, the application I showed just a few seconds ago doesn't have a splash screen. There's other stuff it doesn't do, but I think the most important or interesting thing is its support when JavaScript is disabled. I used to work at a web shop where we were working on a web application for a client, and on our testing on our mobile devices, the website loaded perfectly fine. We were all using Android devices. And our client just kept on expressing to us her disappointment because no matter what she did, she wasn't able to actually load the website on her mobile device. Now, she was using an iPhone. She was running Safari on her iPhone. So in the back of our minds, we thought it was a Safari issue, but we couldn't necessarily pin it because, yeah, we could test on Safari on a Mac, but we didn't have iPhones readily available. So our boss did the most sensible thing, which was to buy us all brand new iPod Touches, because obviously there's no way he's going to spend $700 for iPhones for us, and the iPod Touches were like less than $200 at the time. So we're testing on our iPod Touches, and we still can't replicate the issue where like the site wasn't loading. It loaded in perfectly for us until one day when the client came in for one of our weekly meetings or check-ins that we as the engineering team just asked to see it not work on her phone. And in reality, it really didn't work on her phone until we dug deeper into the settings of the device and discovered that she had JavaScript disabled. Now, this should have been an easy thing to resolve, right? It's just one setting on the user's device, but we had no way of knowing this really, because I don't think it's common for us to expect that a user will have JavaScript disabled. But it's a real situation that could happen. And though you don't necessarily need to support a JavaScript disabled environment, just because a lot of things that we do on the web require JavaScript, it would be good to at least inform a user about a difference of experience if JavaScript is disabled, just so they know, like, hey, nothing wrong with what you're doing, but things might not work the way you expect because JavaScript is not enabled. I put that there from a personal experience and personal pain that I think you guys should consider. So providing some sort of fallback if JavaScript is not available is definitely, in my opinion, super important. Anyway, as it stands now, the application is not fast, it is not integrated, it is not reliable, and it is not engaging. Now, I mentioned earlier a tool to audit the website, and it was called Lighthouse. And Lighthouse is an open source automated tool for improving the quality of web pages. you can run it against any web page, whether it's a public page or one that requires authentication. It has audits for performance, accessibility, SEO, and most importantly, it has a PWA audit. Now, you can actually run Lighthouse in the Chrome DevTools. It's built into DevTools. You can run it as an extension available on Chrome and Firefox, which I typically use just because I feel the results from this are more reliable than the results built into Chrome. And it's also available via command line. So you can install it from NPM. You can use it via the command line, or because it's installable from NPM, you can use it as a module in your build tools, your testing suite, whatever you want to do. You can just use it in your JavaScript code as well. So we have the application now. Let's make it better. And the first thing that we can do is we should make it reliable. Like, this application should be working offline. There should not be any surprises, like when a Chrome dinosaur jumps into the web page telling the user that, hey, this isn't going to work right now, you're offline. So being reliable means no surprises. No one just popping in, no Chrome dinosaurs. And when launched from a user's home screen, the service worker is going to be the tool that enables our PWA to load instantly, regardless of that network connection. A service worker is written in JavaScript, and the best way to think of it is kind of like a client-side proxy. It puts you in control of the device's cache and how you respond to resource and asset requests. By pre-caching key resources, you can eliminate the dependence of the network, ensuring an instant and reliable experience for your users. So this is an example of how that could work. This is a cache-first example, which is ideal if you're building an offline-first experience. So the request might be handled by a web page is requesting a resource or asset. It goes through the service worker, and the first thing the service worker will do will check the cache. That's a really, really fast check just because it's already located on the device. It's just a mapping, like, boom, key value sort of thing. If the asset or resource exists in the cache, that would have been returned to the page. But because it doesn't exist, it goes to the network. So the service worker will fetch the resource from the network, and it'll deliver it back to whatever code you have that's requesting it. However, not only will it return it, it will cache it for future uses. So the next time you make a call to that same resource or asset, instead of having to make a round-trip request to the network to get that information, it will pull it from the cache, being this almost instantaneous loading experience. And so there's definitely other strategies you can apply other than a cache-first strategy. But just introducing a service worker to your site can be an easy way to increase the reliability and perceived speed of your website. Now, if you're an Angular developer, Angular has a schematic that you can install and apply to your projects with the command ng-add@angular/PWA. It ends up adding a lot of things besides enabling the service worker in the build process. And these other things we'll kind of hit on later. But I'd say it's like one of the easiest ways to get started. Now, if you're a React developer, well, at Google I/O in 2017, we announced that Create React App will actually support service workers in PWA as soon as you create your React application, no additional steps required. And if you're a Vue developer, also at I/O of 2017, we announced that the Vue CLI will enable service workers from the get-go when you do the Vue create command. So when you go to create your new Vue application, go to manually select some features, and just enable PWA support. You can continue with the rest of the default settings. You don't need to make any other changes there. But now you have a service worker that will work out of the box. Keep in mind, customizing and configuring your service worker is something you'll still want to look into. While the platforms can guide you with what you could and should do, they can't really know everything that you want to do. Taking Vue, for example, you can modify aspects of the service worker by configuring configuring some settings in the Vue config file, or they actually have an option to configure some of these things with the Vue field in your package JSON. What's cool about this, though, is that both the service worker for Vue and the service worker for the Create React app are both built on top of Workbox. If you're not using any specific framework, you can also and definitely should consider using Workbox as well. It's a library that bakes in a set of best practices and removes the boilerplate that every developer ends up having to write when working with service workers. It handles things like pre-caching, runtime caching, strategies, request routing, background sync, provides some helpful debugging, as well as just provides a greater flexibility and feature set than other service worker tools. Now, it's also available on NPM like Lighthouse. And we actually host a wonderful article about Workbox on web.dev. It's written by Jeff Posnick. He's part of Google's web developer relations team. And he actually specifically works on the Workbox tool. So if ever there was an expert to learn more about Workbox and service workers, he is the person to speak to or talk to or read from. So you can find that article here. It's just web.dev/Workbox. But by implementing our service worker, we now have a web application that is definitely more reliable. And it's faster, fast-ish. But let's get faster than fast-ish. What's important to know is roughly half of users will abandon a website if it takes longer than 3 seconds to load. And once loaded, users expect it to be fast. No janky scrolling or slow to respond experiences. 1 out of 2 people expect a page to load in less than 2 seconds. And roughly half of people say that waiting for a web page to load is what they dislike most when browsing the mobile web. Now, luckily, our service worker can actually address a lot of these concerns. However, there's other ways that we can optimize the initial load of our websites. And that ties into a massive concern with building PWAs and, more importantly, single-page applications or JavaScript-dependent websites. And that concern is really just the cost of JavaScript. So I'm kind of stealing this slide from a friend and an amazing propagandist for the web who works on the Chrome team, Adios Mani. Now, keep in mind, if we want to be fast at JavaScript, we have to download it, parse it, compile it, and execute it quickly. But not all bytes weigh the same. A 200 kilobyte script has a very different set of costs than a 200 kilobyte JPEG image. And this is outside of the raw transmission times for both sets of bytes. They might take the same amount of time to download, but when it comes to processing them, we're dealing with a very different set of costs. A JPEG image needs to be decoded, rasterized, and painted onto the screen, versus a JavaScript bundle, which will need to be downloaded, parsed, compiled, executed. And honestly, there's actually a bunch of other different steps that a JavaScript engine like the V8 engine in Chrome needs to complete. So keep in mind that these costs are not quite the equivalent. But putting this together, it's like JavaScript is being sent down the wire, and it has to be computed in order to render out a single-page application. This takes time. We can, however, take this burden off of the user and put that onto our server with server-side rendering. Luckily, every major framework provides support as a front-end developer who doesn't want to write a full back-end solution. So I'd say these guides are pretty simple. And I kind of glossed over what server-side rendering it is. Keeping it simple, server-side rendering, it'll take the code to render a page that you've written, render it on the server, and instead of sending this empty shell of an HTML file where your JavaScript application gets loaded into, it will send a page with your JavaScript application already rendered in as HTML, as well as the JavaScript bundle. So immediately the user will get the experience because the page will already be rendered out and loaded, and then the JavaScript will take over the rest of the experience. So when they navigate through the application, your JavaScript just handles the rest. Now, I mentioned the first-party solutions are awesome, wonderful, especially if you're a front-end developer who doesn't want to have to write back-end code. But there's also these non-first-party solutions that are definitely streamline the daunting task of configuring your own server-side rendering environments. In the React world, you have Next.js, and in the Vue world, you have Nuxt.js. But again, if you're not using any specific framework, you can use Puppeteer. Puppeteer is a node library which provides this high-level API to the Chrome DevTools protocol, and Puppeteer runs headless by default, but it can be configured to run in a full non-headless Chrome environment. You can do a lot with Puppeteer. You can generate screenshots of pages, you can generate PDFs, you can run tests, you can crawl single-page applications, and most importantly, you can use it to pre-render content, basically providing us server-side rendering support. So like Workbots, you can install it via NPM. And this is a really simple implementation where it's an Express server. It takes the user's request for whatever page they want to visit. It'll launch a virtual Chrome browser, navigate to a new page, being the page that the user requested. Once it gets rendered, it will just close the browser, take the HTML rendered, send it to them. And that way they are getting all the code already executed sent to them. That way their device doesn't need to execute that code. So with that, with server-side rendering and with our service worker, we are now both fast and reliable. The last thing we really want to do is to have our application be engaging and interactive. We want it to feel like a natural app on a user's device with an immersive user experience. PWAs are installable and live on a user's home screen without the need of an app store or Play Store. And they offer these immersive full screen experiences with the help of a web app manifest file. Now the web app manifest file allows us to control how our application appears once it's launched. And we can specify things like home screen icons, the page to load, when the app is launched, screen orientation, so it'll allow us to do portrait, landscape, lock it in to any one of these, and whether to show this in the Chrome browser or not. And it's actually a really simple thing to do. This is a wonderful actual tool that exists. I actually have it pulled up here, where you can just quickly type in the settings that you want. So you can give it your application name. If that name would be too long on user's home screen, you can give it a short name. You can set the theme color, which is the kind of the color in the status bar or your notification bar. So we'll leave that as white. The background color is the color of the splash screen. So when a user pops open the app, that's the color they'll see. We can have this take a full screen mode. Orientation can be any, so we can let the user rotate the device however they want. And finally, we can upload an image. So I have this icon, which is a 512 by 512 image here. Click submit. It'll generate a file for me in a sec. There we go. So it generates a file here. And if I look into this file, I have the manifest JSON, which is actually, let's see if I can open this. So here's all those settings that I have: the movie, full name, the short name, the colors, full screen, but also has all these icons at all these different sizes. So it ends up taking the image I upload and generating all the different icon sizes I need. So all I have to do is take the content of the zip, these two files, and just dump it in the root of my application. And immediately now I have my web app manifest in place. So if you guys want to use this tool, I definitely think it's worth checking out. It's manifest-gen.netlify just Netlify app. And implementing it or using it in your code is really, really easy. Taking this page, this is an example of like my index.html and Angular application. And all I really need to do is add these two lines to the head. One of them is pointing to the manifest JSON. The other one is setting the theme color of the application. Now, with the manifest in place, our application can live like a native application on a user screen. It's fast, integrated, reliable, and engaging. I did mention a bunch of different things that you can do to implement in order to build a more fire application. But keep in mind, there's a ton of other different APIs that you can use on your web applications. You can get access to Bluetooth, USB, multi-touch. You can even get gamepad inputs. So it's definitely worth checking out the other things that you can do. One of these cool new things that are available to PWAs are app shortcuts, which if you're used to on your Android or iOS device, press and holding onto a application icon and getting a shortcut of like things that you can quickly do in that native application. Well, PWAs can do this too. Support on this exists in Android starting with Chrome version 84, as well as in Windows with Chrome version 85 and Edge 85. Implementing this ends up being kind of easy. In that manifest JSON, there's just a new field called shortcuts where you can pass in an array of shortcuts to use. So this is kind of an example. So I definitely recommend checking out these few articles also for other things you can look into when building a progressive web applications. The first one is the app shortcuts, which, like I said, just shortcuts into these different features in your application that users can access from the home screen. The other one is the badging API, which you might have seen in some devices where you might be able to have a little counter of different notifications and stuff like that. Counter of how many missed notifications you have. And the final article is a case study about trusted web activities. I would compare TWAs kind of like Cordova or Capacitor, but just with a lot less overhead. Long story short, it is a simple way for you to take your progressive web application and bundle it to be able to deploy it to the Play Store. So you could build your code base for the web, have it available on the web as a PWA for Android and iOS devices. But if you also want to have a presence in the Play Store, you could pretty much get it deployed and launched in less than an hour in the Play Store by using a TWA or making a TWA. So I definitely recommend taking a look at all of these articles on web.dev. Now, the last thing I wanted to do here is show you the actual popular movie application that we ran Lighthouse against before. And so we're just going to run Lighthouse now. So I'm just going to make sure, yep, we're testing for PWA, and let's generate that report. And at the end of this, that is a lot of green dots, no more red triangles, and one massive green check mark. So it's hitting all the things that we were missing before. It's hitting the 13 or so items that we want in order to build a PWA. If you are interested in the PWA that I kind of have there, it's at pwa.otta.dev. If you want to look at the code in the top right corner, there's a GitHub link. These slides will be available on bit.ly/building PWAs. This is case sensitive, so be careful when typing in the URL. And finally, I am hoping the things that you can take away from this talk will help you build better progressive web applications. Ideally, at the end of this, you'll be implementing these things. That way you can kind of make this Chromosaur go the way of the dinosaur, which is extinct. Anyway, my name is Michael Salati. I am available on the web pretty much everywhere with just my name, Michael Salati. Feel free to message me. I would love to hear back from you guys. Thank you.
Okay, thank you, Mr. Michael. We'll see if someone has a question. Anyone have a question? So let's wait about 1 minute. But someone is questioning, can we add notification feature?
I'm sorry, I wasn't sure. Was that directed towards me or?
Someone is asking, can we add a notification feature?
Oh, so someone was asking if they can have a notification feature. Yes, progressive web applications definitely support push notifications. That's handled via the service worker. I will say it at times can be a bit of a daunting task to implement, but there are tools that definitely make handling push notifications like super, super easy, because typically it's something that might be a nuisance with server implementation. Google provides an amazing developer tool called Firebase. I would definitely recommend taking a look at it as a platform or tool for not just hosting your web application, but just the other tools that it provides. It is a tool that we provide that can make doing push notifications super, super easy. So yes, push notifications, definitely doable with a progressive web application. I would recommend looking into implementing that with Firebase.
Okay, great. We don't have other questions.
Okay, I will. That sounds good. I will exit the.
Okay, thank you very much for your time.
No, thank you for having me.